Catherine and Leslie had a total of 140 sweets. When Leslie gave Catherine a quarter of his sweets and Catherine ate 5 of her sweets, Catherine had twice as many sweets as Leslie. And we're asked, how many sweets did Leslie have at first and how many sweets did Catherine have at first? So what's happening? Well, we've got two people and we've got the total number of sweets. Leslie gives Catherine a portion of his sweets. Catherine eats 5 of hers. So we've got 5 that leave the model at some point. We've got to watch out for that. But we're told that after all this happened, Catherine had twice as many sweets as Leslie. And in terms of trying to find somewhere to start drawing, it's always when you've got some kind of comparison or you're told how, something compares to something else, or you've got some fractions going on, that's really going to help you know where to draw, where to start drawing. So we are going to really start with the end situation and work backwards in effect. So we've got Leslie and we've got Catherine. So Leslie and we've got Catherine. Okay, where would I start? When Leslie gave Catherine a quarter of his sweets, so for me that means that now if Leslie gives Catherine a quarter of his sweets, that means, so if we say that this is Leslie's original bar, okay, and it's split into quarters, and if he gives away a quarter, he's going to be left with 3 quarters. So that's why I'm going to give Leslie a bar that's split. Now, that appears to be into thirds, but it's 3 quarters of the original 4 quarters that he had. So this is after. Okay, and I should probably label that. I'll label that at the end. Okay, that's what Leslie has at the end. And at the end, what does Catherine have? Well, it says, when all this happened, Catherine had twice as many sweets as Leslie. So Catherine has this, which I'm going to divide up in the same way. And Lucky Catherine has another one, another set like that. Okay, there we go. So this is what Catherine has. All right, twice as much as Leslie in the end. Okay. Right, now what? We need to sort of work backwards and see what happened. Now it says that when Leslie gave Catherine a quarter of his sweets, so one of these quarters came from Leslie. Okay, so we could say, let's do, this is from Leslie. Okay, that used to be here, didn't it? And so when Leslie gave Catherine a quarter of his sweets and Catherine ate 5 of her sweets, now, so in this end position, she had eaten those sweets. So there's an additional 5 sweets to add on. Okay, now it doesn't matter how you do it. I noticed that in the textbook answers, they added the 5 onto here. Okay, and you could do it there, or you could do it there. It doesn't matter as long as you are sure of what that means. Let's say I put it here. Okay, so this is going to represent the 5 sweets that Catherine ate. Okay, so she had these sweets, she ate them. She got this from Leslie, And when that all happened, they ended up with this end situation where Catherine has got twice as many as Leslie. Okay, so let's be clear. Let's think about, we need to think about our model to look at how many sweets, we're told, did Leslie have at first and how many sweets did Catherine have at first. So we need to be able to see that. And what I'm going to do is, let's say this is what all the ones like this was with Leslie at first. So all of these sort of blue parts are Leslie's. And what did Catherine have? Well, Catherine had all of this. And she had these 5 sweets before she ate them. Okay, so that's what she had at first. Again, if we had this 5, we could have put that on there, and that perhaps would have been just a neater way of doing it. I just wanted to show that it really doesn't matter. Had you put it on the end, you just could have annotated or made a note on your model to show which bits mean what and what was there at the beginning, what was there at the end. I hope you're following me. Right. Okay. Let's have a look. It said Catherine and Leslie had a total of 140 sweets. That means at the beginning, before the 5 sweets were eaten. So this whole model represents 140 sweets. Okay, how does that help us? Well, look at our model. We've got all these parts are the same, except the only bit that's not an equal part is this 5. If we could somehow get rid of this 5, we would then have a value for all of these parts. So when I say get rid of this 5, we're just going to, so we're going to imagine, what if we took that 5 away? Now, if we take this 5 away, we have to take it away from this value as well, don't we? So that would be 140. We take away that 5 and we end up with 135, which is the value of the remaining equal parts. How many of those are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we divide 135, if we divide that by 9, we get 15, which is the number of sweets that each of these parts represents. Okay. Okay. Right. Let's go back to our question. We must have all of the information we need now. So let's go back. How many sweets did Leslie have at first? Okay, well, at first he had the 4 quarters. Okay, he had all of these 4 parts. So at first let's do question A. At first it's 4 times 15. Okay, 2 times 15, you'll probably know, is 30. So 4 times 15 must be 60. So at first, Leslie had 60 sweets. And how many sweets did Catherine have at first? Well, at first she had 1, 2, 3, 4, 5 parts plus this 5. So if we know that 4 parts are 60, we could add another 15 would be 75 plus another 5 is 80. Okay, so for the B, again, we could just do the 60 plus 15 plus 5, or we've also got 1, 2, 3, 4, 5. We could just do 5 times 15, which is going to be 75, sorry, and then plus the 5 to give us a grand total. However we're going to calculate it, it's a grand total of 80. Okay, so just showing you that there are going to be a variety of ways to work it out. All right, so that's our answer. Okay, I think it's, once it's drawn out like this, I think it's less difficult than it might have looked. And again, it's up to you where you want to put that bit of 5. If you look at the textbook answer, it adds it over here. That's going to depend on your experience and just what makes sense to you when you look at the problem for yourself.